Standard 7 Subject Science Lesson number 18 Sound Production of Sound Part 2. In our previous video we had studied about what is sound and how is sound produced. Now we will start with our new topic, that is periodic motion. When the string of a musical instrument such as a tanpura is plucked, the string can be seen to vibrate, but the two ends of the vibrating string are still. As it vibrates, the string moves to one side of the central position and comes back to the central position. This motion of the string is repeated again and again at a fixed intervals of time. Such motion is called periodic motion. Sound is generated by the rhythmic vibration of an object. We can hear the sound as long as the object vibrates, but when we touch the vibrating object with our hand, the vibrations stop and we no longer hear the sound. Sometimes we can see the vibration, but sometimes the vibrations are so minute that we cannot see them with our eyes. So, the object moves to one side of the central position and comes back to the central position while vibrating. This motion of an object is repeated again and again at a fixed interval of time. Such motion of an object is called periodic motion. Make a list of instruments you are familiar with. Find out which part of the instrument vibrates and produces the sound. Such vibration that produce sound can be studied with the help of a simple oscillator. So, we'll study about oscillator, oscillation and oscillatory motion. You must have seen children playing on a swing in a garden. Observe carefully the motion of the swing. Go to a swing at rest in a garden and mark its position on the ground below it. You can call this mark the central position of the swing. Now pull the swing to one side and let it go. Observe how it swings. The swing will be seen to cross the central position again and again as it moves from one end to the other end of its swing. A swing that moves back and forth like this is an oscillator. When the swing moves from one end to the other and return to its starting point, it is said to have completed one oscillation. So, the back and forth motion of an oscillator on either side of a central position is called oscillatory motion. Take an empty proclaim bowl or an empty steel glass. Stretch a rubber band and fix it on the bowl or a glass as shown in the picture. Now give a jerk to the rubber band. Repeat this action applying a similar or a greater force. While doing this, furthest distance to which the rubber band is stretched. Take note of the sound generated. When the rubber band is stretched and released, it vibrates. Compare the vibration with the figure. When the rubber is stretched from the original position A and come back to the position B, it is seen to be curved. The maximum distance between the original position A and the position B on stretching the rubber is called the amplitude of vibration. Means the maximum distance covered by an object on any one side of its central position while undergoing vibration is called amplitude of vibration. When a greater force is applied to a rubber, it is stretched further, meaning that the amplitude increases. On releasing it, a louder sound is generated. When a smaller force is applied, the rubber is stretched less. Then the amplitude is smaller and the sound is softer too. Now, take a strong thread half a meter long, tie a small iron or wooden ball to it and suspend it from a support as shown in the figure. Such an oscillator is called as a pendulum. Give an oscillatory motion to the pendulum. The maximum distance between the original position A of the pendulum and the extreme position B or C is called the amplitude of oscillation. AB or AC is the amplitude of oscillation. Thank you.